As Hayabusa 2 approached Ryugu, the asteroid's unique shape came into focus. Rather than a typical spherical shape, Ryugu had a flattened, diamond-like appearance with prominent ridges and boulders on its surface. Hayabusa 2 carefully surveyed the asteroid, taking detailed images and measurements. Its mission was to collect a sample of the asteroid's surface and return it to Earth for analysis. To achieve this, Hayabusa 2 first deployed a small lander called Minerva 2, which bounced across the surface of Ryugu, collecting valuable data and images. Then, the spacecraft descended closer to the asteroid and fired a small projectile into its surface, creating a crater from which it could collect a sample. After several attempts, Hayabusa 2 successfully collected a sample of Ryugu's surface material and began its long journey back to Earth, carrying with it a piece of this ancient space rock that holds clues to the formation of our solar system. Samples from Ryugu have made it back to Earth, and now the results are in. Want to know what was discovered? Hit the like button, subscribe to the channel, and turn on notifications to find out. The experts suggest that from samples collected by the Hayabusa 2 probe, essential life elements such as amino acids may have come from space. Asteroid Ryugu is abundant in organic molecules that could serve as building blocks of life. The discovery was made when scientists took a first look at a sample collected by the Hayabusa 2 probe from the asteroid. The Ryugu sample contains several so-called prebiotic organic substances, including various types of amino acids that living organisms use to build essential proteins to regulate chemical reactions and form structures like hair and muscles. These molecules can also be created by various non-living processes such as chemical reactions that can occur in asteroids. The results add further credibility to the theory that the basic ingredients needed to kickstart life on Earth could have been delivered to the planet in its infancy from space. The presence of prebiotic molecules on the asteroid's surface despite its hostile environment, caused by solar heating and ultraviolet radiation, as well as cosmic ray irradiation under high vacuum conditions, suggests that the uppermost surface grains of Ryugu have the potential to protect organic molecules, said the lead author of the research and researcher at Kyushu University, Hiroshi Naraoka. The Japan Aerospace Exploration Agency's JAXA Hayabusa 2 spacecraft collected samples from Ryugu, located about 215 million miles, 347 million kilometers, from Earth, in February 2019. The samples were then returned to Earth in December 2020 and were extracted in Japan in 2021. A small amount, 30 milligrams or about 0.001 ounces, of that sample was then analyzed by NASA's Goddard Organic Soluble Analysis International team in the fall of that year. This new research represents the first organic analysis of the Ryugu sample that will be studied for many years to come. These future investigations will include comparing the Ryugu sample with samples from the asteroid Bennu collected in 2020. We will make a direct comparison between the Ryugu and Bennu asteroid samples when NASA's OSIRIS-REx mission returns it to Earth in 2023, said Dworkin. It is expected that OSIRIS-REx will return a much larger sample mass from Bennu and provide another important opportunity to search for traces of organic life building blocks on a carbon-rich asteroid. Thank you for watching. Don't forget to like and subscribe for more great content. See you in the next video.